as the term might be. You have some more flowstone. It's also called drapery or ribbon formations. Now, all of these form basically the same way. Water from the surface seeps down through the rocks around, dissolving and picking up various minerals as it goes, until it reaches this area of the cave above, building downward and forming the stalactite. Sometimes those drops of water carry minerals with it until it hits the ground there. They get deposited underneath, building upwards and forming the stalagmite.
Chemical weathering. So we're in the process here of watching chemical weathering take place. Down the dip of the rocks that were folded during that last phase of mountain building, the Alleghenian mountain building, that caused these sedimentary rocks to go from flat-lying, how they were formed, to tilted, folded, during that phase of mountain building. This is range view, because we can view many ranges. Okay? So, right here, and you can see the road up ahead peeking through, all right, and the car coming across there. This is the Blue Ridge, all right? So this is the main ridge of the Blue Ridge Mountains. Okay? So we can see the Blue Ridge. And we can see the Blue Ridge Province, all of the hills, all right, that you can see off in the very far distance there, all right. That's that first ridge of the Blue Ridge by Haymarket, okay. So you can see quite a ways down there. Okay? Now just beyond there is the Piedmont, okay. So beyond Haymarket is where the Piedmont begins. This is the edge of the Blue Ridge, right? Because as we looked at on your diagram and talked about where those caverns were, and at Signal Knob, the first stop, we were right at the edge of the Blue Ridge. We're on the west edge of the Blue Ridge province, okay? So over there, all right, that's the Valley and Ridge. Okay? So you can see long, extended ridges, and in between those, of course, are valleys. So we have the three different provinces, right? Two of which we can see very clearly. The Valley and Ridge, okay? The Blue Ridge, extending out for all of these ridges here, right? And then the Piedmont beyond. Okay. Right, and we're sitting again, lots of rocks from the Grenville, the ninth from the Grenville. We have Grenville rocks now on the other side, but you can see how distinctly weathered those rocks are. So we're not going to look at them here. It's not a great exposure here. But at our last stop, which will be our next stop will be our last stop. Okay? Nazca Plate, South American Plate. lots of volcanic activity. Juan de Fuca Plate, North American Plate, all those Cascade volcanoes, all right? So when we talk about the Grenville and what we see of the Grenville rocks, these are the old magma chambers that were the roots or the core of the Grenville Mountains. Just like now, magma chambers are the core of the Andes Mountains in South America. And the same relative to the Cascade Mountains, all right? The Sierra Nevada Mountains in California. These are the old magma chambers that we now see at the surface, okay? So the Grenville is the metamorphosed, or the rocks of the Grenville, all right, the Peddler formation, which you probably read about. The Peddler Formation is the roots or the guts of the Grenville Mountains, these old magma chambers that have gone through metamorphosis. Okay? So the rocks here, when they built, Skyline Drive, right? They, of course, sourced their materials, their rock material, from this location. So many of these rocks here, there are some Catoctin in here as well, but many of these rocks are the Grenville rocks, the Peddler Gneiss. So here's a location where you have this sedimentary rock, all right, that's separating two different lava flows of the Catoctin. And then as you look up, you can see like another ledge there, all right, kind of about 8 feet up, where there's another little break in the actual lava flows that occurred, okay? So just an interesting location, shows you that, lava flows out, there's a period of quiet, and sedimentation takes place, all right? And then we have a second lava flow. There's a location over there where we could see bubbles, vesicles, that are at the top of the lava flow. So that would tell you that's where the air rose toward the surface and got trapped in that basalt lava as it was cooling. All right, so that's another indicator. Like when you find vesicles, you know that you're, towards the surface of that lava flow. All right. Mountains, the magma chambers that went into the formation of the volcanic activity during the collisional process. All right. But this is a nice, well, it is a nice, just a joke. Bad pun, exactly. All right, but this is a good look at some of that exfoliation, the type of weathering where you get the thin sheets of the rock material through the expansion as this is exposed at the surface. So, Peddler Gneiss, all right? But then we start to see these really close fracture patterns here, all right? And these fracture patterns have been caused by extension of that Rhodinian continent starting to break apart, all right? So intense fracture patterns, good conduits for where the Catoctin basalt could start to find its way to the surface, all right? So, what do I have here? The gneiss, the Peddler gneiss. And so the supercontinent of Rodinia was together for about 300 million years, all right? And about 750 million years ago, Rodinia started to break apart. Basically, the large amount of land is trapping heat, right? The supercontinent's trapping heat that needs to escape from the mantle. And so it finds a conduit, right, to the surface and causes the fracturing of that supercontinent. And as it does so, just like East Africa is now, and the Red Sea and the Gulf of Aden have formed from this extensional process, right? A rift valley develops, and the magma makes its way to the surface, all right, through that extensional type of stress, and pours out magma onto the surface. All right. So what's the composition of that magma? It's coming from the mantle.
Basalt.
Basalt, exactly. And that's the basalt rock of the ocean crust, right? So the basalt rock rises to the surface and comes through the cracks and fractures developing from the extension, and then pours out onto the surface. And that's what we're looking at behind us.